Welcome back to geometry class. We're going to continue moving on in our unit on triangles. And we're going to continue actually with triangle congruence. Now, if you recall in the last lesson, we talked about side, angle, side, and side, side, side congruence. In this lesson, we're going to talk about these two, angle, side, angle, and angle, angle, side. So here's the little outline of the lesson, what we're going to cover using angle, side, angle. Proofs, oh yeah, proofs with angle, side, angle. Proofs with angle, angle, side, more proofs. And then finally, determining congruent triangles. So we're going to use some stuff. And we're going to build upon, well, one simple thing, notes. Yay! So we got to learn some more postulates. The first postulate we're going to dig into is called the angle, side, angle postulate. Now, why in the world would we call it an angle, side, angle postulate? Well, take a look. If two angles and the included side. Say, what? So look at we have these two triangles going on here, right? We have an angle that's congruent to another angle, right? A and D are congruent, and then C and F are congruent, right? So we got those two angles. If two angles and the included side, mind you, AC is congruent with DF, that is the congruent side. So we read this as this way, right? Angle, side, angle, angle, side, angle, or we can read it the other way. Angle, side, angle, and angle, side, angle. Okay, so either way, as long as we're reading the corresponding direction, we're going to be cool and noticing the angle, side, angle postulate. So if we have this situation where two triangles have two angles, corresponding angles congruent, and the included side congruent, then those triangles must be congruent. Okay, so another shortcut if we base it off of the lesson in that second lesson we did with congruent figures. So again, we don't need all 6 parts. We're doing another shortcut. One of them is angle, side, angle. So two angles with the included side. Now, on the same token, notice we had two angles going on that are congruent. Well, we have another two-angle congruence theorem, congruence postulate, angle, angle, side. Okay, so either way, we have the two angles, but notice the difference. In this case, angle, angle, side, the side that's congruent is not included in the two angles, dudes and dudettes. So check this out. You can read it, again, similarly. You can go angle, angle, side, and angle, angle, side. Or you can also call it side, angle, angle. Shh, don't tell anybody I said that. But it's the same thing. You can read it the other way, right? You can go side, angle, angle, or side, angle, angle. Okay, but either way, it's another congruence postulate. So if you have two corresponding congruent angles and a non-included side, that is angle, angle, side congruence. So these are the notes that we're going to build everything on, and we'll even get in some proofs and all that stuff. So this is a good time to pause and rewind if you need to. Go ahead and do that, but I'm going to keep moving on. So let's get into some fun stuff, right? So we have a couple examples we're going to go into. We're going to use the angle, side, angle postulate. Now remember how we do this. It's angle, side, angle. And so which two triangles are going to be congruent by angle, side, angle? So take a look at this set of triangles here. We get 3 triangles, and we're going to take a look which two are congruent by angle, side, angle. So if I look at the first triangle, USV, let's say, and I see one arc angle, a 1 tick side, and a 2 arc angle. That's the same thing going on in the other triangles. 1 arc, 1 tick, 2 arcs, 1 arc, 1 tick, 2 arcs. So which two are congruent by angle, side, angle? So I have to look for two triangles that have angle, side, angle. And remember, the angle is included. So take a look at triangle USV. We have angle, side, angle. Right? So we have to find another triangle that fits that description. And so first I'll give you the wrong answer, which is this one. WTA is not the right triangle, because this doesn't have an included angle, okay? Or the included side, sorry. So the side is not included. Kind of like batteries on my favorite toys. The side is not included. Battery is not included. So this side is not included. So it ain't that one. It's got to be triangle EON, right? So we have angle, side, angle. And look at how I read that, because you got to go from the corresponding parts. Correspondence matters in this business, and we'll keep talking about that. So just remember, correspondence matters. All right, so that's how that example works. Same question. Which two triangles are congruent by angle, side, angle? So take a look at the next three triangles here. Take a look. We're looking for two triangles congruent by angle, side, angle. And I'll give you the one that's not it. And which one is not it? You're not it. You in the middle, you're not it. How do we know? Because this triangle goes angle, angle, side. That's angle, angle, side. So no, that is not it. It must be the other two. Angle, side, angle. And again, correspondence matters. 1 to 2. Angle, side, angle. So those are the two triangles that are congruent. So that's how using angle, side, angle works. Okay? Okay. So if that was too confusing, pause, rewind, check it again, and make sure you listen, dudes and dudettes. So if it was confusing, make sure you listen up. So that's how it works. Let's have some fun. Proofs, boys and girls. Yay! So now let's go into proofs with angle, side, angle. And so I'm going to give you this triangle, this diagram here. And I'm going to give you a whole bunch of givens that are givens. So we got the angle CAB is congruent to angle DAE. Now time out. Before you keep reading, where the heck are these things? Where is angle CAB? Look for it. CAB. And then angle DAE, DAE. Oh, so guess what? All this sentence is saying, this sentence is these 1 tick marks, or the 1 arc marks, okay? So that's all that sentence is saying, that those are congruent. And now we have, okay, so segment BA is congruent to segment EA. Now time out before you continue. Where in the world is that? So segment BA is here, and EA is here. Now notice how they're written. Correspondence matters from the outside in, segment BA, and then from the outside in, segment EA. And so again, the one tick segments, those are congruent, right? And then lastly, angle B and angle E are right angles. And so this is all set up. We know what right angles are, right? So that's all set up. Here's what we have to prove. We have to prove triangle ABC is congruent to triangle AED. We're going to prove that. Now, you might be looking at the picture and thinking of the last examples where we looked at triangles being congruent by angle, side, angle, and you may be wondering, cats, do we even need a proof for this? And the answer is yes. Yes, we do. We do need a proof for this because we have to exercise our ability to use logic. So clearly, normally I talk about game plan with proofs. Here there is no game plan. We're looking at the finished product. Dude, angle, side, angle. We have it, right? Like, Mr. Katz, can I just put this to you and say it's done? The answer is no. No, you can't. And here's why. So let's take a trip down here. How do we start proofs? We start with some given stuff. Now, notice how I'm going to start with my given statements. I'm only going to start with the first two. Why am I only going to start with the first two? Because logic matters. We're going to set up a rock-solid argument where logic matters. So I'm going to start with the first two statements, kind of like what we did in the previous lesson. Let's throw some givens out there. But I'm not throwing all three. I'm only throwing 2 of the 3 given statements. Why only 2 of the 3? Because of logic. And I'll talk about that in a second. So anyway, I'm going to start with my 2 congruent angles and my 2 congruent segments. And I'm going to start that as given. Okay? Now, I'm going to separate that third given out. And I'm going to put a star next to that because it's a very important logical reason I did that. So I'm separating out that third given, that angle B and angle E are right angles. That is also given. Why am I separating that out? Because notice what this doesn't tell us. This doesn't tell us angle B and angle E are congruent. It doesn't say they are congruent, and that's important. So it doesn't say congruent, and we have to establish that for angle, side, angle. That is a huge logical step. Okay? So this given statement doesn't say congruent. It just states that they're right angles. We have to use that logical jump and actually claim that angle B and angle E are congruent. And in order to do that, we have to state the given that they are right angles. Now, how in the world are we going to make the jump from there to there? This is a very simple yet important argument to make, but you have to make it. So how can we state that angle B and E are congruent? We can state that because, right, again, try not to say duh, right, but this is important. All right angles are congruent. We have to establish the congruence of those two angles. So we can't just say, yeah, they're both right angles, angle side angle. We can't do that. We have to say they're both right angles and they're both congruent and then angle side angle. Okay, so now we have our congruence. Okay, so now we can say our triangle is congruent. That is such an important piece. And I wanted to show this example to emphasize that we can't make the jump from right angles to angle side angle. We have to establish that they are congruent. That is a key element in our use of logic. Okay, so we have to do that, and that's important. So if this was confusing, again, pause, rewind, and listen carefully because I explain everything. Okay. Next, more proofs. Yay! So now let's do another proof, but this time we're going to use that the other note. Remember the other note? Now we're going to use angle, angle, side. Okay, so now we're going to talk about angle, angle, side and how that works. So let's do a proof with angle, angle, side. Here's the setup. Now the setup is going to be nuts. Okay, we have the given statement: angle M and K are congruent. Okay, so we have the arc there, and the only other given is that segment WM and segment RK are parallel. Only those two given things, we're going to prove these two triangles congruent. And how we're going to do that? With angle, angle, side. Now, we have to now establish a game plan. This is not like a clear-cut proof. And in fact, there's a couple ways to do it. But I'm only going to show you one of them. We have to come up with a game plan. Here's our game plan. We got to think. Right? Put your thinking caps on. For angle, angle, side, right? We need another angle, right? Because currently we only have one congruent angle. For angle, angle, side, which is what we're doing, we need another angle. How can we establish another pair of congruent angles? We think we have to use those parallel lines. Because if we have parallel lines, guess what WR is? WR is the transversal. No way! Yeah, way. Okay, so if we have parallel lines, WR is the transversal. And that way we can establish two more congruent angles because of the alternate interior angle theorem. Now, which two angles do you want to establish as congruent? This one and this one is alternate interior angles, or this one and this one? It's up to you, because honestly it doesn't matter. First things first, we're going to get there. So let's get this thing. We have our game plan in mind. We have to get our two angles, and of course we need a side. So we look at this, and if you remember anything at all from the previous lesson, I hope you know how to get a side that is congruent. Okay, so anyway, let's move on. Let's get this bad boy started. So the first things first, I'm not going to throw both givens down. I'm going to go ahead and start with the first given. Angle M is congruent to angle K. That is given. That establishes our first angle. Okay, so angle, check. Right, so we got that first angle. Now, what do we need? I'm going to establish our side. And this is what I wanted you to remember from the previous lesson. We have to establish the side that's congruent in the two triangles. That segment WR is congruent to itself. That is the reflexive property of congruence. We have to do that. So remember that from the previous lesson. So if we have that set up, right, boom, we have our segment, and now we have our congruent side. The only thing we need is our last angle. Right? So what are we going to do? We have to start using that parallel. So why did I not use the parallel given up here? Because I'm going to use it for my angles. I want to just go ahead and knock out my side. Did I have to do it this way? No, you don't. But I do it anyway. So now, I kind of like scrunch this up. So now I'm going to use the given parallelism, right? So segment WM is parallel to segment RK. That's given. Now, why am I going to do that? Because I'm going to go ahead and establish a couple of congruent angles. I'm going to state that angle RWM, let's take a look at it, RWM is congruent to angle WRK. WRK. I'm going to establish those two as my alternate interior angles. Now, did I have to use those two? No, I didn't. I could have used angle MRW and angle KWR. I could have used these two as alternate interior angles. I just didn't. I could have, but I didn't. But I'm going to establish those two. Now the argument, again, just like we covered in some of the previous units, if lines are parallel, and we must say if lines are parallel, then alternate interior angles are congruent. Okay? Or you can, if you want to cheat a little bit, call it the alternate interior angles theorem. Okay? Anyway, so we have that set up. Now we have our third angle. So third angle, check. So now we have angle side congruent. And now we're all done with that proof. Okay, so that's a good one. This is a good proof. We have to establish a couple things that are necessary to do. Okay, so remember we came up with a game plan, had to get our second angle, and then we had to think it through and use that parallel given in order to get ourselves there. So hooray for logic. Again, confusing? Pause, rewind, listen. Next, more proofs. Yay. So more proofs with angle side. Once again, we need two angles and a side. So here's our diagram, and here's the given statement. Angle S and Q, got it. One arc, we're all set. And now here's this interesting thing. Segment RP, now where is segment RP? Okay, right there in the middle, segment RP, bisects angle SRQ. Where's SRQ? SRQ is over here. Okay, that's interesting. RP bisects that bad boy. And we're going to prove these two triangles congruent. How? Well, let's think. We got to think. What in the world is a bisector? So you got to remember what a bisector is. A bisector cuts the angle in half. Okay, so an angle bisector cuts the angle in half. But then you got to know, what does half mean? Half means two equal parts. So the game plan is, if RP is the bisector of that big angle, then the two little angles that RP creates are congruent, dude. That's the game plan. And now we have angle, reflexive side, right? So we have our game plan. All we need to do now is write it out. So let's begin. I'm going to start with one given at a time. Okay, so I'm going to talk about angle S and angle Q being congruent. I'm going to stop there. Now why? Because I want to use the bisecting given for the next thing after it. Okay? So now I'll say that segment RP bisects angle SRQ. Now I'll say this given. Why am I separating that? Because I'm about to use this one to make it a clear, logical progression. So now I'm going to use that thing. Now I can state that our angles are congruent. Angle S, well, I went to SPR. I should have went SRP. Oh well. You get what I'm saying. I'm fixing it. Angle SRP is congruent to angle QRP. You get what I'm saying. Now why is that? Because the definition of an angle bisector. Angle bisector cuts the angles in half. We have our congruent angles. Now, funny enough, we can't say, we can, but we can't say that it's the same thing. But don't worry about it. Anyway, you know I'm talking about these two. So what do we have now? We have two angles, right? So we got congruent angle with S and Q, and we've got congruent angles from the bisector. All we need now is our side. How are we going to get our side? You guessed it, reflexive property of congruence. Blah, blah. Segment PR is congruent to itself, reflexive property. So segment RP or PR is congruent to itself. And now we have our side. So we've established all three congruent things, and now we have our angle side congruence. So it's really, really important to step-by-step logic our way through this. Okay, we're going to have to logic the heck out of this stuff, and that's what we're doing. Okay, so that's proofs with angle side angle and proofs with angle side. So now let's go on to can we determine congruent triangles? So let's take a look at this question. It's a multiple choice question. So we have this diagram on the right-hand side here, right? And the question is, which statement best represents the answer and justification to a simple question? Is triangle BIF, time out, let's look at triangle BIF. Reading matters. BIF, okay? So look at that, reading matters. Is it congruent to triangle UTO? Again, reading matters, UTO. So that's the question. Are the two triangles congruent? So let's take a look at a couple of things. Remember, first of all, that correspondence counts, and it's all about the reading. Okay, so how are we reading? So if we look at B going this way, okay, if we're looking at B going this way, or even this way, triangle BIF, we'd have angle, angle, side. Okay, so if we can start from I and work our way around. Angle, angle, side is what we have. Or if we're going the way we're reading, we would have side, angle, angle. So if we read it going one direction, we'd have side, angle, angle, side, angle, angle. If we read it from the other direction, we'd have angle, angle, side. So notice the difference. Okay, so I'll call direction one the way we gave. Side, angle, angle. And I'll call direction two angle, angle, side. Okay, so it doesn't matter which as long as you're reading them both the same way. So if I read triangle, the first triangle in the way number one, side, angle, angle, I'm reading it this way, clockwise, right? I'd have to do the same thing. Now remember, clockwise, this was side, angle, angle. What's clockwise for the other one? Angle, angle, side. Interesting. That's interesting. So is that the same thing? If I read it clockwise, I get side, angle, angle, or angle, angle, side. If I read it counterclockwise, I have angle, angle, side. And if I read the second triangle counterclockwise, I have side, angle, angle. Very interesting stuff that's happening here. So if I read it way number one, it's not the same. I'm missing a corresponding piece. And if it's way number two, again, it's not the same. I'm missing a corresponding piece. So let's look at the answers, right? We can say, yes, the triangles are congruent by angle, side, angle. Is that true? Absolutely not. Angle, side, angle has an included side, so there's no way that's the case. How about this? No. Segment FB and segment OT are not corresponding sides. Well, let's see what it's talking about. Segment FB and segment OT are not corresponding sides. As a matter of fact, that is a true statement. So take a look. FB goes this direction and is adjacent to the one arc angle. OT goes in this direction and is adjacent to the two arc angle. They are not corresponding sides. So guess what? We cannot say that these two triangles are congruent. We need more information. Okay? So we can't say these two triangles are congruent. We need more information. So it's all about the reading. Correspondence counts, and it's all about the reading. If I read the triangle in one direction, I have to read the other triangle in the same direction. And I won't have corresponding parts. Okay, so I can't say that the triangles are congruent by angle, angle, side because that's not the case. Okay, they're not corresponding. Clearly that last statement is not true. Angle B and angle U are not, yes they are. Angle B and angle U are totally corresponding. That's not true. They both have one arc. So there's that. Now that can be kind of confusing, so that's a good one to pause, rewind. Okay? So now let's look at this one. This is a fun example. Again, determining congruent triangles. Are triangle PAR and SIR congruent? So let's point to it. PAR and SIR. Are they congruent? Well, we got some thinking to do. The first thing we got to do is look for correspondence. So take a look. We've got PAR and SIR. Do we have correspondence going on? Well, let's look at, if you remember from the first lesson we did, or the second lesson in the unit, we can tell correspondence just from here. So if we have angle P is corresponding to angle S, and angle A corresponds to angle I, and angle R corresponds to angle R, right? So we have to look for correspondence. So take a look. According to the letters, angle A corresponds to angle I, right? So if those two angles are congruent to each other, we're all set. Are they congruent to each other? Is angle A and angle I congruent? Ding. Okay, so we got that. Chickadee check. Okay, so that works. Now, let's look at the letters. We have segment PR and segment SR. Are they corresponding? Yes, yes they are. Why would I ask? Because look at the diagram. We got PR and SR being read this way and being read this way. Totally corresponding. Correspondence counts. Looks for correspondence. So check here. And then lastly, Vertical angles are always congruent, so guess what? Angle R is congruent to angle R. We are all set. We now have angle, angle, side congruence. Angle, angle, side congruence. One arc, two arcs, side. One arc, two arcs, side. Okay, so yes, we win. These are congruent triangles. It's all about the reading. It's all about the correspondence. Okay? So let's do a couple of quick quizzes. So in the first quiz, we have a given angle XWY. Where the heck is that? Okay, so we have XWY, this little arc here, is congruent to angle ZYW. ZYW, this little arc here. All right, sweet. Angle X and angle Z are both right angles. Sweet, all set. Now, how is it that we're going to prove that YXW is congruent to YZW, right? How can we prove these two triangles congruent? Now, here's what I'm going to do. I'm going to activate cheat mode. Cheat mode activated. How in the world are we going to establish this without writing a whole proof? Well, remember the reflexive property. WY is congruent to itself. Okay? So we have the reflexive property. We can totally establish that. Now look at the picture. We will have angle, angle, side, congruence. Angle, angle, side, congruence. Angle, angle, side, angle, angle, side. We have angle, angle, side congruence. So now, this is a multiple choice question. How can I activate cheat mode? Remember what our game plan was. We can prove this using angle, angle, side. So now look at these. Look at these answer choices. Cats, this is crazy. You have to read all of the given here and the thing in there. And I'm like, no, dude. Take a look at the answers. Is that angle, angle, side? No. Is that angle, angle, side? Yes. Is that angle, angle, side? No. Must be B. Cheat mode activated. So anyway, the angle, angle, side congruence is how we do it. So that's that quick quiz. How about another quiz question? This is a good one. I love this one because I remember my college geometry class was this question. Anyway, which of the following best represents the answer to the justification to the question, are these two triangles congruent? Take a look at this diagram. Are the two triangles congruent? Now, here's what we can do. We have our congruent sides, right? We have our congruent angles. Clearly, we have one more congruent side, reflexive side, right? So we know that AC is congruent to itself. Do we have congruence? So let's take a look. 1 tick, 2 ticks, angle. Side, side, angle. 1 tick, 2 ticks, angle. Side, side, angle. Is side, side, angle a thing? And the answer is no. Side, side, angle is not a thing. So let's explain that in a second. So here's the example. We only know that segment DC, we only know that length by looking at it. Okay, we can only tell segment DC by using our eyes. And as we know, life lesson, don't judge by your looks. Okay, so don't judge by your looks. We only know segment DC by its looks. We don't have congruence between BA and DC. We just judge it by its looks. Now here's an interesting twist. Segment AD could possibly have another position and all the given info would still be there. Segment AD could be in a different position but still be a 1 tick segment, and here's how. It is totally possible for AD to be down here and still have 1 tick. Okay? And that, again, DC, we only know DC by looking at it, which is a horrible way to live your life. Don't judge by looks. Okay, so don't do that. So it's totally possible that exists. Now, clearly they're not congruent. So side-side angle is not a thing. So can we answer the question? No. There is not enough information to establish congruence because side-side angle is not a thing. And that, my friends, is a cool thing to understand. So hopefully you do. I hope you enjoyed this lesson. Feel free to watch it again and rewind. So just remember, what did we do? We talked about triangle congruence using angle, side, angle, and angle, angle, side. And we'll be back later with another awesome installment. Peace.